automatically gives P equals MC. Huh? Yeah, a perfectly competitive society. So we get to this point, just thinking like that, that from the Marshallian, Pigouvian, this is other guy we'll talk about this briefly, we get to the point of the argument that marginal cost equals price is the formula for the optimal allocation of resources. That is the best output for society and the output that society wants, right? So if price equals marginal cost for every commodity, that gives the optimal allocation of resources, okay? That's the Marshallian derivation. Now, this turns out to be kind of intriguing. How would Marshall though says, oh, but by the way, that's not absolutely right. Why not? Marshall's the guy who put together the demand function. I think did I ask you this question in this exam?
Yeah.
So what did Marshall have a problem with about demand and consumer surplus? How many of you know the answer? Eric is the only one? The rest of you don't know what the problem is with the demand function? Ooh. Why do we, okay, and what is the problem, Erica?
That money itself is a commodity, so it's subject to diminishing returns.
Yeah.
And so the demand function, we have to compensate it to cancel out the income.
So it turns out Marshall, this guy's actually pretty amazing, because I read him all the time, because I have him for my history of thought. He's writing in 1890. And if you, I tell you, if you pick up his book and start reading, not the first, I think it's got 6 books or something, the Theory of Political Economy, whatever it's called. I think it's Principles of Economics. The first book is kind of stuff about just kind of, general economic junk, not really getting to it. But when it gets to a discussion of demand and supply and all this stuff like we know, it's really amazing because he says, and he's the one who says it, demand intersecting supply gives the optimal allocation, competition gives the optimal allocation, except for this. Demand is not a true reflection of the demand in society, i.e. the demand that really tells what people want, because it's distorted by income. And he says, in almost any society, a redistribution of income would change the demand function and increase, produce a better allocation of resources, which is pretty amazing. So Marshall says, for us to think that the competitive market optimally allocates resources is to assume that the demand function is not corrupted by different, income distribution, by some people rich and other people poor. Since it is, it does not give you optimal allocation of resources. Okay, everybody? Now notice this. One of these days I get a chance, in another year or so, I'm going to be writing this article. A guy comes up, an Italian named Pareto, Alfredo Pareto, and derives something called the Pareto principle. Now the Pareto principle is intriguing for what it is. By itself it's kind of intriguing. And it results in the same answer as Marshall got, that is, optimal allocation of resources implies P equals MC. And we'll also say this gives us 0 efficiency loss, okay? We'll be able to measure that. But Pareto's result, which we now do in modern economics, completely is independent of income. So Pareto's approach, which dominates economics now, is completely independent of considerations of income. It just assumes people have certain income, and then it gives you the Pareto result. So in this room, depending how income is distributed, we have different Pareto results. All right? So I say to you, this is kind of intriguing. Marshall put this all together, showed the competitive markets were the best of all possible worlds, but then showed this was dependent on the distribution of income. It could be improved with a better distribution of income. But Pareto was the one that the economists really bought into because he proved the same result, but independent of changes in income. I don't think it's accidental. Anyway, here's the Pareto rule that you all have to know, okay? It's a standard rule. It's used everywhere in economics and outside of economics. It's this rule. In a room like this, we're going to exchange. Everybody, we're going to just exchange. We've got various things. I'm going to exchange with Alina. Maybe I like her jacket, and she likes my shoes or whatever. So we'll figure out an exchange rate. And so on and so forth in this room. The Pareto rule is this. We can exchange with each other. Exchange goes on until any further exchange makes one person worse off. One person worse off. All right? One person. Not a bunch of people, one person worse off. That's the Pareto rule. It's extremely restrictive in some ways. So for example, let us say that in this class, we have when's our next exam? July 19th or something? Something like that. Example. Aliens land in Toronto. They're kind of landed somewhere like in Queen's Park or right here on the campus. And we know when they're going to land, and our exam is at that time. And really, it would be kind of neat if we didn't have our exam and we saw these aliens landing in Toronto. But it turns out, according to university rules, we cannot change our exam date once it's set 2 weeks after the class starts, unless we have complete unanimity. If one person in this class says, no, I don't want to see these aliens, I want to write the exam, we have to all write the exam. Literally. So that's the big flaw about Pareto optimality, despite the fact that it's always used in economics as a basis. So for example, building a subway obviously makes some people worse off. Right? So, okay, now I'm going to ask you to articulate the Pareto rule. Kyle, can you do it?
Wait, can you explain why making the subway makes people worse off? How does that even...
Okay, somebody explain.
Jobs away from people who don't make something.
Subway construction is annoying, right? Because if I'm driving, the subway interrupts my driving. You know, it turns out they're starting the subway in Eglinton and I can't do what I want to do. It's noisy. It uses, by the way, it bids up the price of concrete. So if I'm fixing my house, it costs me more for concrete. Of course, you know, it's a ludicrous rule, virtually everything. Every high-rise built in this city contradicts the Pareto rule because you're inconvenienced. You notice they take part of the road, for example. All right? Okay, this is the Pareto rule. All right, so the Pareto rule is, now Kyle, can you tell me the Pareto rule?
Yeah, so basically you just give and take until it disbenefits one person.
Yeah. Trade can continue until one person is worse off, then the trade must stop. All trade is acceptable except any trade that makes one person worse off. The Pareto rule. But the Pareto rule, figured out by the way with the difference curves, basically with the difference curves, results in it gives the result that Pareto optimality means that P equals MC. Okay? Good. Now then, people, here's what we're going to do. We're going to do the next part using the Pareto rule, and I'll show you that, and it's going to take us 5 minutes. You are going to okay, diagram. We're all going to do this diagram. I'm just going to wander around when you're doing it, okay? So everybody do it. Number one. Oh, I draw the diagram for you. Everybody? This is your exam in July 19th. On July 19th. This is your demand function. I just give you this. I wouldn't say cost, I wouldn't even say cost per unit or cube. I'm just going to give you the line. Draw the demand and that. This turns out to be, by the way, the average cost function. But I'll just tell you, this is the average cost function, and this is the demand function in an industry. Draw it carefully, just the way I did. See where this is not in the middle. This is maybe in the middle would be about here. Look along here, if you had a line like this, everybody notice? If you had a line, say, like this. This would be there. Is this a natural monopoly? Yeah, what's your name, sir? Yeah.
Andre.
Why not Conrad?
Andre.
Andre?
Andre.
Andre, oh, Andre, yes, sorry.
Because it's on the left side of the metric.
Yeah, exactly. And also you can see other competitive firms could enter. There's room at long run equilibrium. This firm would be producing this amount. Another firm the same size would add this amount. So there could easily be 3 firms in the industry in long run competitive equilibrium. So this is not a natural monopoly. All right. I want you to show me monopoly equilibrium, price and quantity, and economic profit or loss. If you weren't here, just do your best. Okay, what's the monopoly rule? You know the monopoly rule, right? You know the monopoly rule. What's that? What's the monopoly rule? Yes. Now just tell me the rule. What's the rule for profit maximization? I know, but you behave like that's difficult.
No, I don't know what to do.
No, but help me mess up. Everybody, marginal revenue with marginal cost. Do it. Find marginal revenue, find marginal cost. If you guys did this exam, you all know where the one we just did today, and didn't perform disastrously, you all know where marginal cost is. And you're going to tell me where marginal revenue is. Do you want to later? Okay, so hang on. Okay, where's marginal revenue?
It's twice as deep as the demand.
Yes, exactly. So everybody, this is like a piece of cake. It's always the same. Marginal revenue is twice the slope of demand in this diagram, and we'll do the same thing, of course, with equations and stuff like this. So it's going to bisect. You know, in the midpoint right here, its total revenue is at a maximum. Elasticity is 1. Boom. Marginal revenue like that. Okay, marginal revenue and marginal revenue through minimum average cost. Now, if you don't know that, time to wake up. And this is vertically the monopoly quantity is determined right there where those two intersect, and the price is determined from the demand function at that output. Notice the monopoly basically gets a quota for itself. It finds the output that maximizes profit. It gives the price in conjunction with that output that maximizes profit. So you know this was what was put in here. This is marginal revenue of the monopolist, and this is marginal cost of the monopolist. Okay, and of course for the monopolist, by the way, here's the average cost at that output for the monopolist right there. Again, just reading it off. And here is the economic profit or loss of the monopolist right there. Now I'm going to get that out of the way because it might confuse things for us. Now, sorry, just leave that there. Actually, I'll move it out of the way. Okay, now, my question to you is simply this. What is the output that gives the optimal allocation of resources? What price and what output gives the optimal allocation of resources? I.e., what is the output and the price that's best for society? Yes, Nate. Oh, no, go ahead. Yeah. Where MC equals P, right? Now notice, that's where supply intersects demand. Because MC is, of course, supply of a competitive firm. It's not supply for a monopoly, but it's the supply of a competitive firm, like that. So it turns out, the argument is, this output gives the optimal allocation of resources. And in our time-honored fashion, we can see why. Now let's think. Notice everybody, look here. As society produces more units of output going up to here, let's say right here, for example, there's a society, they stopped here. But at that point, somebody in society is going to pay this price, and the cost of that extra unit is only this. So literally, society can produce that extra unit for $10, say, and somebody's willing to pay 15, so we should produce that unit. It's worth 15 to somebody, but why not produce it? So if we produce it, we get to this point, all the way up to the point where it's worth, someone will at least get more from it than it costs us, right? Then we get to this point. If we go beyond that, this is what's an aim. For society to produce beyond that, nobody values that. There's nobody out there valuing that extra output as much as it costs it. It costs society more to produce that output than somebody will pay for it. Everybody? So this is absurd. So that's the intuition on it. Okay, now, it turns out then, so that we're going to do that. That's going to be, I'll call that P star, but notice it's perfect, it's competition. This is the optimal allocation of resources. Then we're going to ask, and this is the last thing I'm going to give you today, what is the efficiency loss at monopoly equilibrium? And what this means is, what is the loss to society in basically consumer surplus and producer surplus? But that's one way. I'll show you that we can do that as well. But we say, how is society producing inefficiently? Basically, and we say, society is producing inefficiently if there's any output that would give us, if we produce more output, it would be worth more to people than it cost us to produce that output, marginally. Or is there any output whose marginal costs more than society is willing to pay? So it turns out, efficiency loss, I'll just show you, over here, if for some reason, please don't put this in, just try to understand it, because if you put it in at this stage of the game, with this diagram, you're not going to just confuse, and we'll come back to this later. Supposing society was to produce this output. Supposing, for example, someone said, well, society should produce up to the point where price equals average cost. Because that kind of makes sense. Why don't we produce up to the point where price equals average cost? But notice, it would mean that all these units beyond Q star, we're producing them, but they're actually, to produce an extra unit costs us more than society is willing to pay. Look right here. Even though price equals average cost, the person who actually buys this unit, if they buy it, it's only worth this much to them, and it costs us this much. So, in fact, this area below marginal cost and above the price line, demand, this would be the inefficiency loss to society of producing too much. In our case, because the monopoly restricts output, the efficiency loss is the difference between what it's worth to society, the demand function, and the cost of these extra units. Okay, sorry for a second. Yeah, that's terrible. There it is, all right? Efficiency loss to society. We'll pick it up when we get back. Have a nice reading week.